Okay, we have a participant today. Can you want to tell me who you are?
Lucas.
Let me turn up my volume. I didn't quite hear you.
Oh, my bad. It's Lucas.
Okay, Mr. Clark.
Awesome.
How are you doing today?
Pretty good, you?
Okay.
Awesome.
Okay, very good. Did you come with any questions today?
Not really. This week's stuff, most of this, I think I said this last time I was here, but we went over a lot of it in pre-calc last year. So I just kind of like a lot of this week, this unit's just kind of been reviewing stuff, you know?
Right. Well, if you don't have any specific problems you want worked, then I'm pretty much tied, or my plan is to just kind of randomly pick them out.
Awesome.
Okay, so you got no problem with that?
Yeah, sure. That works fine.
All right, well, I'm just going to randomly pick out problems here through 4-5 and then finish with 4-6. Probably take 30 minutes or so.
Perfect. Sounds good, man.
Okay, if you got any questions, feel free to
I'll let you
speak
know.
up. Okay,
Perfect.
sure thing. And, if you got other things to do in the middle of it or whatever, no problem at all. I'll just sit here and work problems and record it and post it to YouTube for people.
Awesome.
Okay. All right, so for 4-5, 404, I try to remember the ones I've already done. I won't totally repeat them. Why don't we try one like number 23? It says 2 to the 5 minus 7x equals 15. Where I'm getting this, if I can. Okay. And once again, I'm going to use ln, even though it doesn't match either of these bases, rather than mess with logs of other bases. So I take ln of 2 to the 5 minus 7x is equal to ln of 15. And I bring this to the front, 5 minus 7x, ln of 15. I'm going to divide both sides by the ln of 2. 5 minus 7x then is equal to ln of 15 divided by ln of 2. Part A, they want an exact answer in terms of logarithms. So I'm going to go negative 7x equals log of 15 divided by log of 2, subtract 5. When I divide by negative 7, I'm going to reverse it and write it 5/7 because the two negatives will cancel. Subtract 1/7 log of 15 over ln of 2. Now, that may not be the exact form that they have. This would be the answer to A, exact answer. And B, they want it approximated. They want it 6 places. Can you believe that? 6 places, little anal. I could spell approximation. So I'll try to punch away here, pretty much like it's written. 5 divided by 7. I'm going to go subtract ln 15 divided by, then a big parentheses, 7 ln of 2. Hope I got everything lined up. 156, let's see, they wanted 6 places. 156, there's 4, 6 places, the 4 is less than 5, so 156, 158. Again, on the test, I won't be that anal about the 6 places, and I won't mark it true or false if you ask for sig, you ran it to 5 or whatever. I try to be more obvious than that. I won't get that picky. Let's see. I don't know if we should check the first one. 4-5-23, wasn't it? Find the section number. 6-3. 4-5. 23. Okay. All right. Yeah, that's basically it. 5/7 minus log 15 over 7 log 2. And the part B is, yeah, 156, 158. So pretty much right on it. Let's see. Further down. I don't think I've done one like 37. Again, chime in if you got any questions.
Will do.
Okay, minus x equals 4 then. So there's kind of some beginning algebra. You don't just want to charge in with logs until you got e by itself. So clear 1 plus e to the minus x. So I go 1 plus e to the minus x times 50 minus x equals 4 times 1 plus e to the minus x. So that will clear the fraction, leaving 50. I'm going to distribute through 4 plus 4 e to the minus x. Could divide by 4 since it's factored out. You can play it either way. All right, now I'm going to subtract 4 minus x. And now I'm going to divide by 4. And you could leave it 46 over 4. I'm going to leave it 23 over 2. I guess I reduce it 23 over 2 equals e to the minus x. Now I'm ready to take, and ln is a nice choice because it will directly undo that. So ln of 23 halves, ln of e to the minus x, and ln then of halves is equal to minus x. And we can divide by -1, divide by -1, and we get the part A exact answer. X equals negative ln of 23 halves. And we can approximate it. In part B, negative ln 23 divided by 2. 26 places it says 1, 2, 3, 4, 5, 6. All right, 4, 4, 2, 3, 4, 7. 4, 4, 2, 3, 4, 7. So yeah, it's all about undoing what's here. I think I did 39 and 41. Let's try 43. Still on the same page, 404. Got a little more you get some factoring in this. Solve 2 to the x, subtract 10, 2 to the minus x, add 3. If you notice, this x to the minus x is not double. So it's not a direct quadratic form. Let's write it 2 to the x minus 10. That's not 102. That's 10 times 2 to the minus x. And we're going to put the 2 to the x on bottom, 2 to the minus x on bottom becomes 2 to the x. When you switch levels, the power changes sign, plus 3. All right, now we're going to clear the fractions. Multiply through by 2 to the x. I'll do a big distributive property. 2 to the x minus 10 over 2 to the x, add 3, 2 to the x, 3, close, and then equals 0. Yeah, the 2 to the x is still factored out. All right, so a 2 to the x times 2 to the x, the powers add x plus x would be 2 to the 2x. Here you're getting it canceling. Minus 10, add 3 times 2 raised to the x. And I really shouldn't have closed parentheses. I should have closed it here, but 2 to the x times 0 is still 0. So it might look like you're only doing one side, but you're actually doing both sides, just that the 0 doesn't change. All right, so rearrange 2 to the 2x, add 3 times 2 to the x, subtract 10 equals 0. And now you have what you want. This is double. So it factors with a 2 to the x and a 2 to the x. And you're going to want it, what multiplies to negative 10 and adds to 3. Looks like it would be a positive 5 and a negative 2. Double check. There's your 2 to the 2x minus 2 times 2 to the x. Add 5 times 2 to the x would be a positive 3 times 2 to the x. 5 times negative 2 is a negative 10. You want to call this factor 1, factor 2. Factor 1, 2 to the x plus 5 equals 0. 2 to the x equals negative 5. You can do your log on both sides, but you're just going to see you're going to have a problem. This is illegal. Hope we've gotten that across. You cannot put negative numbers into logs. So there is no solution. No solution. 2 to the x will never equal negative 5. There's no x value for which that'll happen. Number 2, though, it will work. You almost do it in your head. You see x got to be 1, so the 2 minus 2 is 0. But we'll do it out with logs. 2 to the x would equal 2. ln 2 to the x equals ln of 2. If you want to do them all the same way, x ln of 2 equals ln of 2. So you divide both sides by ln of 2, and x will equal 1. So that's the only legal answer out of that. Pretty long, a lot longer than a lot of the others. Should we pause for any questions? Got anything?
I'm good.
Okay. I think we did both 45 and 47. I think I remember doing them both. Why don't we charge down to our log equations here? How about, I don't recall doing 53. Base 2 of 3 plus a log base 2 of x equals a log base 2 of 5 add of x minus 2. So what we can do is combine both sides, combine logs on both sides. So you can write that as a log base 2 of 3x. You would expand back out as log 2 of the first, add log base 2 of the second, because they're all positives, so they're on the same level. This side is a log base 2 of 5 times x minus 2. Because they're all positive, they wind up on the same level multiplied. Now we can undo 2 to the log base 2 of 3x. Base 2 of 5 times x minus 2. Oh, I froze. I'll be back. It froze. Please come back. Oh, okay, there we are. Maybe it'll all of a sudden it wants to freeze. Okay, so then these undo, they're inverse functions, leaving us the 3x equals 5 times x minus 2. 3x then is equal to 5x minus 10. Subtract the 5x over. Let's not divide. Subtract the 5x, so negative 2x equals negative 10. X would have to be 5. Divide both sides by negative 2. X would be 5. And remember, you need to check, is this legal? Well, you can put it up here, put the 5 back. You almost do it in your head. Log 5 is legal. Log 5 minus 2 is legal. Yes. Only positive logs when you sub in. Page. don't really have to punch it out. It'll work punched out. What you're checking for is if it was a quadratic, you got some negative numbers, and maybe you end up with a negative number from the factoring, and that would not work. Either here or here, a negative -2 would still be negative. All right, and further down the page, we're at 15 minutes. Try one more, and then we can maybe jump on to 4-6. I think I did through 63. I think I did 65. I remember the base 9. Let's try 67. This might be a little long. And I froze again. Okay, I'm back. Log base 5 of x plus 1. Log base 5 of x minus 1 equals 2. So when I combine on this one, we'll get a log base 5 of the positive 1 on top divided by the x minus 1 on bottom. It'll catch up. Not working like a well-oiled machine all of a sudden. Okay. Because the negative log there leads to a term on bottom. And if you expanded it back, you have log of the top minus log of the bottom. That equals 2. Now we undo with base 5. Going 5 to a log base 5, x plus 1 over x minus 1. Don't absolutely have to parentheses, but on this side it'd be 5 to the second power. That's why it's very important to realize you're raising both sides to an exponential. Even like on last problem, you had a log on both sides, so it seems a little superfluous, but very important when you don't have a log on both sides. You're going 5 to those powers. This undoes. That leaves us x plus 1 over x minus 1 comes up 25. And we can clear the x minus 1. X plus 1 over x minus 1 equals 25 times x minus 1. Cancels. So x plus 1 equals 25x minus 25. And so this is not going to be a factoring or anything, just x's to the left, numbers to the right, minus 25x. Negative 24x plus 1 equals negative 25. It'll catch up. Doesn't seem, can you still hear me?
Yeah, you just came back in. It was lagging for a while, and I think the video is still pretty frozen.
Maybe I should go ahead and stop the share and see if I can restart it. Well, no, now it's trying to catch up.
I saw movement for a second.
Yeah, I moved for a second, wrote that one little thing. You know, I'm one line lower. Maybe I should stop the share and see if I can jolt it. Let me do that. I'm going to stop the share and see if I can jolt it.
Okay.
So we'll be back. Okay. All right, let's see how long it'll work. So you see I'm one line lower. x minus 25, that's negative 24x plus the 1 equals negative 25. So then we subtract 1. Negative 24x equals negative 26. Divide by negative 24, divide by negative 24, and we wind up positive. I guess I'll reduce it to 13 over 12. And once again, is this legal? Well, you almost don't have to, I could write it out, but 13 is bigger than 1, add 1, you'll stay positive there, and being bigger than 1, subtract 1, you'll stay positive there. So yes, it will have all positive log. It will have all positive logs. All right, well, that gets us into about 20 minutes in. Why don't we jump to 4-6? And these have a lot of parts, so I might probably only get one in the 30 minutes. We try number 7. I think I've worked 1, 3, 5, 1, 3, and 5. So this is 4.6, page 414. Number 7. Population of a country has a growth rate of 3% per year. So R is 0.03. The government is trying to reduce the growth rate to 2%. Population in 2011, population is 110 million. That'll be its end 0. Find the projected population for year 2036. Find in 2036. Back over so you can see. So yeah, they're not giving you the model, so to speak, or the formula equation to use. It's basically going to be, I can point it out in the section. It's basically going to be this. The N0 is the front coefficient, that's 110 million. The rate's 3%, and you'll use an E. Population at time T, etc. R is rate of growth, and T is time. So we're going to use N of T equals N0 E to the RT. So N of T then is 110.03 because we're doing part A, and part A said R was 3%. The R 3%. T. Uh-oh, went unstable again. Maybe it'll catch up. All right, so population 2036. So here's what we got. They're calling 2011, that would be the T equals 0 year. It'll catch up. Gone only. Okay, here it is. Okay, so in 2036, basically you need the difference. I think you're 25 years. 36 minus 11. Yeah.
It is working perfectly. And sorry, it took a while for the
Okay.
to catch up, I think.
Okay, but you're back. Let me know my.
Yeah, it's all working now.
All right. So yeah, it's just a matter of plugging in 25 for T. So N of 25, and this will be the population in 2036. Would be 110 e to the 0.03 times 25. Well, I don't know why I'm writing it again. No need to write it twice. Why I did that, I have no idea. Just brain there. So 110 E 0.03 times 25. 232 million, 0.87 million. All right, then in part B, they say reduce the growth rate to 2% a year. 2. So be the same, 20, identical. We're just changing 0.03 to 0.02. Be 110 e to the 0.02 times 25. If I really want to shorten it up, I can call it back, second enter, and just run over and change the 0.03 to 0.02. 181.36 million, say. We don't make a big deal about units, but they're technically millions. Well, that's pretty close to our 30 minutes. Is that enough for today?
Sure.
All right. Have you got anything else? You want to say anything else or have anything else? All right, so our last Zoom meeting for the week will be at 9 o'clock tonight. And I don't know if you want to come out then, but you're certainly welcome to come out then again if you want to see more of this. Otherwise, we'll.
Oh, I was apparently I was muted.
Oh, okay. So you need to say anything else? Or?
Sorry.
No problem.
I was responding, but I was muted. I didn't know that I was muted.
Oh, okay. All right, so do you have anything else? Otherwise, I was going to end the meeting. Okay, we'll end the meeting.